everyone, and welcome to my presentation. And thank you all for coming. I've got a couple of prizes I'm gonna hand out in a while. I'll ask for questions, and at the moment there's only two, but at the moment your percentage of likelihood of winning is quite high. So if you ask a question, then that'd be great. So my name is David Watkins. I'm located in Dubai. So it's a tough job, but somebody has to do it, right? And I'm going to talk to you about how we at Juniper are going to help you transform your data center to a private cloud. So what does that transformation look like? And I'm really going to focus on some of our automation technology, plus also how you integrate that with other solutions to provide an end-to-end solution. So I just wanted to take a couple of minutes. By the way, I should ask, who knows Juniper? Good. Who knows data centers? Everybody have a data center? Excellent, that's a good start. So the first thing I wanted to do is just kind of set the scene. So market conditions, and hopefully these will resonate with you. It's actually my first time here in Romania, believe it or not. So I'm not sure if this all resonates exactly with Romania, but I'm sure you'll let me know. Anyway, so what are the challenges that you guys are faced with in your data center? We're just coming out of this post-COVID impact, and we've all been limited by CapEx spending on things like remote access, SD-WAN, SASE security, and so on. And now the focus has come back 3 years later behind the investment cycle to the data center. So we've had to sweat our asset for another 3 years in many cases, and now we're looking for transformation. Therefore, we have an aging IP fabric. So with many of you, I don't know how many of you, have had your fabric maybe in the data center maybe 5 years plus. But there's at least one over there. So it's time for a transformation. And then there's been the supply chain issues. So on our side, we've all seen it. We've been at times up to a point where hardware has been at like 365-day lead times, which is incredible when you think about it. So we're now coming out the other side of that, but all the vendors have been impacted. So people have had to almost forward order in order to prepare for that. And then one which really impacts what we do is what we call the Great Resignation. So where people through COVID just left our industry and went to open a coffee bar or go to the beach or whatever, and it's getting harder and harder for professionals like us to recruit or keep hold of the people with the skill sets that we require. And when we pay for those skills, we want them to be really impacting the business and designing and architecting, not really doing simple operational tasks that we could push down to a lower level. And that's a lot of what our data center automation solution is about. We've all been impacted, or we have obviously we have AWS here today. So there is this tendency for CIOs to think, okay, now we can take all of our applications and push them to the cloud. We can push them to what I call Jeff Bezos' network. But then, with that come a lot of challenges. It's a black box from a networking and security perspective. You have to retool, you have to rebuild your tooling to be able to see your applications into that environment. And then, if you do that in AWS, and all of a sudden you have an application in Azure, then you have to retool all over again, because guess what? Building that environment in Azure and building that environment in AWS is different. So there are these complexities of pushing applications to public cloud, not to mention the escalating costs. And it turns out that rebuilding or upscaling or bringing your data center, transforming is the word I was looking for, transforming your data center, your own on-prem data center is actually much better from a cost perspective than necessarily pushing all of your applications to the cloud. So I'm not saying you shouldn't push applications to the cloud. There certainly are cloud applications that that's useful for, but also, majority of your applications, you might have data sovereignty restrictions, you just might have operational restrictions that won't allow you to do that. The other thing is, of course, who's got Kubernetes in their environment today? Yeah, so I mean that's interesting from a networking and security perspective, and how to stitch that into your environment. And we'll go on to talk a little bit quickly about an application we have called CM2 that will allow you and help you with that. But now you have to contend with not only many of you hypervisor who's got NSXV or NSXT in their environment. Yeah, so you've got hypervisor, you've got maybe old bare metal applications, you've got Kubernetes. So how do you continue to manage that environment, stitch it all together, provide security across that, and the agility that you need in order to transform the environment? And all of our CTOs and all the business, in fact, is screaming for a very agile, very programmable and automated infrastructure. So, if you're going to rebuild your on-prem environment, you need it to be as agile as the cloud. I mean, for sure, if you go to AWS, you can spin up a virtual machine, you can connect it to a load balancer or a firewall, like you can do it like that, right? So in our environment, you need to be able, it's no good waiting for 2 weeks until the virtualization guys can enable it. You need to have much more agility to be able to move forward. And then finally on this slide, you have a change in the way that we build modern fabrics. So we've all moved to spine leaf, 3-stage class, 5-stage class, collapsed spine architectures in some cases for edge computing. We have ERB versus CRB. I know these are technical details, but ERB versus CRB. And of course, the modern way that you would build a fabric if you're starting today is with EVP and VXLAN. And that provides a lot of benefits, but it can be complex. So just quickly, the building blocks that we have at Juniper that we can help you with today. I'm going to talk very briefly about the DC fabric, so the underlying hardware, very briefly, and software. I'm going to talk more about intent-based automation. So this is really the piece that's going to provide you operational efficiency in the data center. And if we have time, and I don't run over, although I've got a lot to pack into this presentation, I want to talk a little bit at a high level about our Kubernetes environment, or how we provide networking and security in that environment, and how we integrate that with our underlay, our fabric in the data center. And although I hate the phrase zero trust applied to the data center, of course, within all that we do, we have to provide security, end to end, and the data center is no different. Any of you use Juniper typically for SRX in the security environment? So you guys will know that we have a very complete solution in that space, and that's important when you're considering the transformation that you're about to go into. So what I'm going to do now is I'm going to go through all of the boxes on this slide with all of the ports and the speeds for you. No, I'm not going to do that. That's not what I'm going to do. To be quite honest, all of this really is what I think as that American phrase, table stakes. So in order to be considered by you as customers, then you have to have this breadth and depth of product line in the hardware space, in order to be able to fulfill your requirement, simply put. And all of these devices, we have merchant silicon, and then we have our own custom silicon for certain use cases. But essentially, this is our portfolio. We do have, this is really data center, spine leaf, border leaf, and so on. We also have access level switches and so forth. But you need to have this breadth of product line, and this is like a world-class product. So, in our competition in the space, there's really 2 or 3 vendors that we compete with, all of the time, and you just have to have the table stakes in order to do that. So we do, and these are all EVPN VXLAN boxes. They can fit in different locations and depending on your use case. Some of them have, deep buffers here and here. Some of them are equipped for high density 400 gig and will be 800 gig in the future. But essentially these boxes are, as I said, table stakes. These are the things you need to be able to play. From a software perspective, Junos has been around how many years, guys? Probably almost as long as I have. Right? It's probably as old as me, almost. Not quite. I like you, man. You might get a bottle in a minute, even without a question. I like that. So Junos has been around a long time. It's a very robust. It's a service provider grade operating system, and I mean these are all the features that we have been working on over the last year or so. EVPN, DCI stitching between data centers, interoperability with the likes of Cisco and Arista on IRB, symmetric, and so on. So these are all details. Micro-segmentation, enhanced loop detection, Rocky 2 security. These are all, again, table stakes. And, we put amazing amount of engineering effort into this. So I'm not belittling it in any way, but, you have to be there. So you guys can be confident that we have the software that's going to be able to deliver for you. We're going to have the features that you need. So this is, again, just a level set that situation. And one final thing on platforms is, this is an eye chart, but sorry for that. This is actually something we did for a customer in Australia, and this was a comparison of emissions of our boxes versus, you can probably read if you can get close enough, against our competitors. And there is a 30% efficiency over our competition, just in terms of power. So I think when you're looking at a hardware platform, for your refresh, for your transformation, make sure that this is one of the details I think it's worth looking into. You can make a 30% saving in power. That's not running full out, that's running on an average cycle for the switches. So I would really, and we're an engineering company first and foremost at Juniper, so we engineer our boxes, better than most. So I think it's definitely something, this customer, certainly it was something that was kind of eye-opening that they hadn't really considered. Okay, so any questions so far? Those 2 bottles are still there. Okay, cool. So I'm now going to spend some time talking about Astra, which is our intent-based automation platform. What does intent-based mean? Oh, this is a good question. Anybody want to have a go at intent-based, what that means? You can say it's declarative model or something like this. Simply put, the way that I say it is, it's a software system that you provide user input to that then models the outcome of what you want in the fabric. Okay, so think of a satellite navigation or Google Maps on your phone or an Uber. You don't go to that system and tell it, I want to turn left here and then I want to turn right on the next roundabout, go to the airport, take the highway. That's not the input you give. You just give your objective, right? This is where I want to get to. I want to avoid highways, and this is my destination. And the software figures out the outcome. And that's what an intent-based system like Astra does, simply put. And I'll put some more meat around the bones of that for you in the coming slides. These are the founders of Apstra. So Apstra was an independent organization before it was acquired by Juniper 2 years ago. And what I would say is, just because you're a founder doesn't mean that you're the best looking guys, right? So Sasha, Mansour, and David. But the reason I've got this slide here is because they had some specific goals which are there to really help you guys. One is speed and agility without risk. So to be able to move faster, to build faster, to expand and deploy faster, but not incur risk. We've all seen, the outages that you get when somebody does a misconfiguration of BGP, like Cloudflare last year that were down for 4 or 5 hours because they had made a BGP misconfiguration, right? So usually, unfortunately, the errors are human error. So a lot of this speed and agility and modeling is giving you guardrails to eliminate human error. And this is a key piece of what Apstra does for you. To be able to scale out and scale up with ease and simplicity and cost efficiency. And it had to be multi-vendor. So before we were actually part of Juniper, we didn't even support Juniper actually in the early days. We supported Cisco and XOS, we supported Arista EOS, we supported Dell, but with Cumulus and other derivatives of Cumulus. We don't support Cumulus anymore, we support Dell Sonic, so Enterprise Sonic as an operating system, and you cookie cut the build of the fabric, so you can go back and select any of those vendors kind of at the end of the build process, and then we deploy all the configurations for you. So it's very, very simple, and it's vendor independent from a switching fabric perspective. So I'm talking about the spine and leaf and the border leaf switches and the access switches that are in the fabric itself. And so what they ended up building was this operating system which takes you through the whole design, build, deploy and operate process. And of course, this operate process is disproportional because this with Apstra, this design takes you about an hour. It used to take you about a week on Visio and whatnot, right? This takes you about an hour designing. Build, obviously, once you have your switches, that doesn't take you very long. It takes you, hours where it used to be days and weeks. Because we validate everything as you bring the fabric up and as you deploy and then operate, that's from day 2 to week 350. As you operate this environment, as you change it, you add more servers, you add new VLANs, all those daily mundane operational tasks that you have to do. And I described what my definition of his intent is. Anybody want to have a go? For a bottle? Anybody want to have a stat? A software system that takes user input and models the outcome. That's simply what I call it. It's the only single management platform that does all these things, and the important thing about that is you end up with a single source of truth. So this source of truth is it describes exactly how your fabric is running at that second in time. And as you keep the operations, you add your new VLAN, you do it through the interface, so it's updated, so it's always current, and it always describes exactly what your fabric is doing at that specific moment in time. That means it's assured and repeatable. And we'll go into a bit more detail there. And like I said, it's the only multi-vendor solution in the switching fabric. So if you go to our competitors and you say, I want to build a fabric including Juniper switches, you probably won't get a good answer, right? They probably won't be very happy about that. The simple fact is their software doesn't work that way. Whether that's Cisco or Arista or whoever, their software only helps you define a fabric, of their switches. And what that means is you don't have choice. You've got some form of lock-in, right, to them. You want to expand that fabric, you still have to go back to them with us. you can decide in a new pod, you can put different switching fabric. You can use Juniper if you want to, and if you like our switches, but you can also use Cisco or Arista or Dell Sonic. Make sense so far? Okay, that's good. Just a little bit more on this. I probably covered most of this, but you go through the design, build, deploy process, and then you get to the operational, and this is a continuous validation. So what we do from the switches is we take the current operational state and we take all the telemetry and we marry those two. This is really important. We marry those two things together. So the telemetry is directly is a direct interpretation of what is actually happening on. Otherwise if you've got all this telemetry and then you've got all of this state, then you have two things which don't relate to each other. So everything we do in our database, our back end, it relates exactly to each other. And that's powerful. Question? We have an agent which sits on the device. Well, we have an agent. It can sit on the switch. So it can sit on NXOS or EOS, as an example, and Sonic. And it keeps pulling the telemetry, and when any of the counters change, then it pushes that information back to the Apstra console. And that, it then gets compared to the current state. And I'll go into a little bit more detail. We have these analytics devices called probes, and these are not hardware probes that you connect into your network. This is a software probe, which basically is contextual to the data that's being pulled and the current state of the environment. And these are very useful. So in day 2 operations, root cause identification, so comparing your intended state with your actual state, and then being able to drill down and figure out exactly what is the root cause. That is gold dust, right? That is powerful, because then you can go right to the root of the problem and you can resolve it. And I'll show you a little bit more detail on IBA probes in a second, if I may. Now this graph, this slide looks like very detailed and technical, right? So let me tell you what it's supposed to represent. These are obviously your spine leaf and your fabric, and these are your switches. This single source of truth that we have, the repository of all the state and the telemetry information, is represented by a knowledge graph. So if you guys, who knows what GraphDB is? No GraphDB, no Google disciples here? So GraphDB is essentially this nodal view which allows you to connect here, in this case, it's the spines and leaves, which are the big red dots, and then the servers, and then at the physical level, so you understand connectivity, the physical level between the spine and the leaf, from a physical perspective. But you also then understand that at layer 2, for virtual networks, VLANs and so on. And you also understand what that means for EVPN, and you also understand what that means for BGP. So you have this exact map and context of everything that's talking to everything. And what we can then do is we can run analytics which query this graph, and in the presence of change, when you have unintended change, this is a very, very powerful thing. Now, as you can imagine, we have just 5 switches here, and we're already starting to get what is quite a complex nodal sort of interconnectivity. Imagine that if you had in your data center, 4 spines and 100 leaves, switches. The complexity starts to get beyond, what it's very easy for us as human beings to interpret. So the ability to have this data related in this knowledge graph then allows you to do this, which is what we call our intent-based analytics probe. So this is simply a pipeline of knowledge graph queries that when connected together will give you an outcome and lead you to the root cause of something. So because we understand the connectivity at all levels, contextually we know what's going on, we can use these software pipelines, and they just sit there on the dashboard until such point as some unintended consequence occurs, and then they will alert you that has happened, and you can go and root cause that issue. There are, if it sees an unintended operational state, of course, if it sees an intended state, then it's fine. Unintended, it will allow you to resolve, recommend, or notify. And I'll show you an example. We have an integration with VMware NSXT, which allows you to, which makes use of one of these probes to alert you to issues with the overlay interacting with the underlay. Does that make sense? IBA probes. Okay, so here's the NSXT thing. So like I said, the NSXT, it's a great tool for allowing you to provide micro-segmentation and those services, obviously virtual machines and so on, and connectivity across the fabric. And it does know somewhat about what's happening in the fabric, but it certainly does not control the fabric, and it doesn't understand a lot of the lower level stuff that's actually going on in the fabric. So from an NSXT perspective, it has an expectation that the fabric will be there. But what about if that VLAN is not in the right place? What about if somebody misconfigured the VLAN? When it's at the NSXT level, it's expecting VLAN 10111, but actually in the fabric, the engineer entered it as 10111, right? Operator, human error. So what we do is we continuously, we actually poll NSXT manager for the current state, where all the virtual machines are, the EXXI host, what even the MTU sizes are, what the VLANs are that they're associated with, and the lags. And using one of these probes, we detect whether there's a mismatch. Now, what we don't do is we don't go back to an NSXT manager from the Apstra interface and push configuration to NSXT manager. We don't do that. What we do is we stay there and we monitor the environment with the IBA probe, and then if a mismatch is occurring, then this probe, it's kind of, here we go. This probe will pop up on the screen, and you've got 7 anomalies here. Oops, sorry. So you've got 7 anomalies that have been detected here, and this is a hypervisor missing a VLAN configuration anomaly. So it's directly going to the root cause of the problem, and what it will allow you to do is it will allow you to directly remediate from here. So remediate the fabric to marry with the NSXT view of the world, and then life is good, right? And then everything is fine. Question?
Yeah, my start because I was wondering, is there any failure rate for this code? I mean, if they may miss an unintended event?
Failure? No. I mean, not that I know of. It's a good question. Would you like a bottle? Sorry, you asked the question earlier. You should have had the bottle. No, I know, but you asked earlier, right? You don't want a Juniper bottle? It's very expensive. I'm not going to walk all the way over there, man. So I'm sure. But no, it's I don't see that as a possibility, to be honest. Thank you. There was another couple of questions.
Yeah. So, what size of a data center is it expected to run this kind of tool? Because if it's a low or low change data center, it's kind of hard to select the management that will. In case our network engineers make mistakes, we're gonna buy a tool. They're gonna say, no, fix the mistakes.
Yeah, so to answer your question, it can be a 2-switch, edge fabric, or it can be a 1,000-switch fabric. It doesn't matter. You use the same tool and it scales up all the way through. This was one of the founders, design, tenets to begin with. So we have a collapsed spine. So when you build the environment and you come to the end, what runs is what we call a blueprint, and that's your map of exactly how your fabric's running. That blueprint can be 2 switches, it can be up to 1,000 switches. And honestly, as you click through the interface to design it, the design could take 30 minutes only, and it will take 30 minutes if it's a 2-switch fabric or a 1,000-switch fabric, because the software is just building the environment for you. Question? With Mist? Currently no, but that's on the roadmap for this year. So one of the things that's happening in Juniper is, integrations of these. The Mist was developed first over the 128T, which is the SD-WAN platform, and also, AI obviously is a very useful tool, and you refer to Mist and you've seen how useful it is in that environment. The thing about the data center is you don't want it to be probabilistic. In other words, you don't want to speculate about the way the fabric is. You have to know, and this in Abstra, you know how the fabric is because you designed the fabric from the beginning. You know what I mean? So having said that, you're going to start to see things where we're bubbling up anomalies through these IDA probes that then will be mystifying, to provide the AI intelligence.
You will start that.
How
easy it is to move on license? Because I know that the licenses are per device. Now, one of my devices is old. I have a spare one.
Yeah. There's
We take directly without contacting the support person.
Yeah, there's no restriction at all. It's an honor-based system, so you're right. It's a license per switch, so it's very, very simple, and it's an honor base. So if you say you have 10 switches and you buy 10 licenses, then you're good. And if you change the switch, in fact, one of the features that we have. You may have seen on the demonstration is undeploy the switch for whatever reason. And if because you undeploy the switch, everything doesn't go red because you're undeploying it from a position of intent. You know you're undeploying it, so the rest of the screen doesn't go red, all the downstream effects of that, like an NMS would. You undeploy the switch, you do whatever maintenance you have to do on it, you put the new switch in. The only thing you have to do in the database is you have to acknowledge the new sort of system ID of that particular switch, but then you can push that and deploy that switch back into the place. So that's one of the operational features that really saves you time and money, frankly. Yes, I'll go for you've been waiting.
Are you able to see what it will automatically remediate in case of an issue? The button on the screen before you click it.
Yes.
Does it show you what it will do?
Yes. And it also it has there are 2 states. So there's actually 2 copies of this state database. There's the active one, and then there's the standby one. So you make all of your changes in the standby. It queues them all up, and then when you're ready, you push them across into the active blueprint. So for every blueprint, you actually have 2 copies of the blueprint, standby and active. And then, look, we have guardrails around everything, we model everything, But if an unintended issue happens, then we have something we call Time Voyager feature, which then allows you to go back to the previous snapshot. It's a bit like in Junos, where you can go back to the candidate version of the operating system, but that's the whole fabric. So essentially, this gives you a huge comfort factor that you can reliably push configurations, changes, or any changes, and the worst case scenario, you'll be able to roll it back. Yes, sir?
Can you integrate the anomaly back into the intent? So you had a certain intent, an engineer went and did intentful modification directly on the switch to change a path.
Yes.
You discover that that's actually a good thing.
Yes.
And now you got an alert. Can you?
Yes. The answer is yes. So you can. We are not preventing you making a configuration change on your switch. There are, situations where you're on the data center floor at 1 in the morning, and the only way to rectify that, which you've got approval for, is to make a configuration change. What we'll do, it will be alerted by a probe. So a probe will pop up and say, you have a diff. Would you like to accept the diff, or would you like to reverse it? Okay, that's the way we deal with it. Okay, guys, I'm running out of time rapidly here. Thanks for the questions, though, so that's good. I wanted to talk about APIs. So what's happening is with our customers is, so you've got your system kind of locked down, your fabric under control, but of course, that's not the only system. We've already talked about an SXT, which you can use to manage your virtualization and your server environment. But you've probably got some sort of ticketing system, ITSM. You might want to deploy applications, keeping in mind this is the transformed data center of the future. You want to be able to deploy applications of which the fabric is only one piece, right? And you've got maybe Kubernetes or different applications that you want to deploy, and people use different tools for doing that, as you know. So our web interface, which you may have seen, just simply consumes our API. So given that everything is consumed or everything is available on the API, that means all the features and functionality you can do from any system that you would like. You can write a Python script if you would like, and then it will all be validated. ServiceNow is very popular. Anybody use ServiceNow as their ITSM? Okay, good. So you can, in your service catalog, you can do simple and mundane tasks. This one is actually adding a VRF, so adding a tenant, and you put all the details in here, the VNI and so on, and then that just gets pushed to Apstra, validated. We won't just push the configuration, we validate it, and then assuming everything is okay, then when that is actually pushed to devices and everything is good, then we will return back to ServiceNow to let it know that's done. You can also integrate any sort of custom middleware. So example here would be Ansible, or maybe Python in a Docker container, and then you can push the output to any of these types of a Slack channel, Teams, or whatever. A couple of examples quickly. Whoops, sorry. This is an Ansible playbook for a customer. So what they wanted to do was have this Ansible to have this scheduled job. Essentially, it goes to Apstra, picks up all the anomalies, goes to ServiceNow, picks up all the current tickets, compares the two, and then open closes service tickets. Just so that you know exactly where you're at from a issue perspective. So that was one, and this is actually what it looks like in our dashboard. So you've got 8 BGP anomalies here at this moment in time, and then using a Python script. This was one where, so in Apstra, you maintain the IP addresses. So you basically have IP, VNI address, loopbacks, and so on, all the pools there. And simply, the system just goes and picks the next IP address, ASN number, or whatever. But you can also use something like NetBox or Infoblocks or whatever, And this is a Python script running in a Docker container. So it goes and looks, for a new IP pool detected. Does it exist? Yeah, yes or no? So it's been created in Netbox, but this script looks in Abstra. Is it there? Yes or no? And then it will create the new IP pool if you need that. So these are just some simple examples of the type of prelude, if you will, that you can put in between these things and that's what it looks like in Abstra. And then what I was kind of alluding to with the application end-to-end is we also now have a Terraform provider. So as you know, with Terraform, it's sort of executable documentation. It maintains, like Abstra does, it maintains state. It can consume config it didn't create. I think who's the software guy here? I think it's called idempotency. Is that right? Idempotency. Anyway, it's this idea that if you keep creating something, you run the script, you run the Python script 5 times and it's the same. You don't want 5 outputs. You want the first output, and then you don't want any more, right? Because it's just overwriting itself. It's just this is the idea. So it's just it executes itself once, and therefore it can consume config it doesn't create, and you can use this to do an end-to-end deployment, including Abstra now. So we have the Go SDK, which will allow you to do that. Okay, guys, I've got like 1 minute left, so CN2 is going to be very quick. Just to let you know though, so CN2, so the issue or the challenge might be in your Kubernetes environment that the plugins for Kubernetes are not very robust from a networking perspective, right? And they're quite basic. And they also have, like with NSXT, they really have no understanding of the fabric that's below them. And of course, Kubernetes now, it could be running in your on-prem environment or it could be running in the cloud. It basically expects a big mesh below it, and like I said, you can stitch together workloads across, or you want to be able to stitch those workloads together across cloud and on-prem. And also, how do you connect to VMs? How do you connect to bare metal? Right? That's not very easy to do in a Kubernetes environment. So what we have is CN2. So CN2 basically deploys into the networking. It's a networking plugin on the Kubernetes clusters, and you deploy Juniper Abstra, and you've got an integration between the two, so you can go to Abstra from the CN2 environment, and you can query Abstra, understand what the underlay environment looks like, and then CN2 can actually push configuration to Abstra, which then gets validated in the normal fashion. So you're starting to really be able to integrate these two worlds together. And what does that help with? Well, that also helps with bare metal and the virtual machine environment. So you can now manage your Kubernetes cluster, but you can also manage connectivity to these by using the API integration with Abstra. One final thing, Juniper Connected Security. So if I can just hold you for 1 minute more, and I've still got one more bottle to give away, so questions welcome. When you look at the enforcement points across the fabric in the data center, and like I said, I hate this phrase for the data center, zero trust to me doesn't apply to the data center. It applies to sort of SASE and SD-WAN and so on, but I don't see really how zero trust plays out in the data center. My perspective, marketing. So, thank you. We have DC-WAN gateway, we have the cloud interconnect, we have intra-DC, so these are all functions that you probably need in your data center. And with Security Director, which is our security platform, you can meet all those use cases that we just described. You have a single policy experience across all of those, and of course that allows you to transition to new architecture. So if you have to have a hybrid environment, on-prem hybrid or cloud, then you can use these SRX in all of those environments. This is what it looks like. And just finally, very finally, we also have an integration now between Abstra and Service Security Director, which simplifies the automation of this piece. And also, we also have, as we mentioned, integration between NSX and Juniper, but we also have an integration here as well. So you're fully integrated. How about that? Thank you very much for listening.